Okay, so I'm looking at our 6.1 homework right now, and taking a stop at number 5 to make sure we're clear on how to find these critical values for a confidence interval. So we're thinking about how many standard errors to the left and to the right of our point estimate that we would want to build our confidence interval around. So one thing we want to be able to picture here, if we wanted 83% confidence, and in this particular section, we're only talking about the standard normal curve. We're talking about the z distribution. We're assuming that the population standard deviation is known, so we use the z distribution. So they're asking us for a kind of a unusual level of confidence, 83%. Right, so I draw 83% in there. I need to think about what is in these two tails. Okay. Well, if I have 83%, that means there's 17% divided by 2 in those remaining two tails. So each one of those tails has 0.085 in it, right? So there'd be 0.085 in here and 0.085 in here. So the z critical that I'm looking for, right, this value, this guy here is going to be negative. This one over here is going to be positive, but they're the same number. So if you remember a couple chapters ago, we could find these z-scores that had a particular percentile with our inverse norm feature on the calculator. If I do inverse norm 0.085, okay, with a mean of 0 and a standard deviation of 1, that will get me there. Or if I just simply add the 0.085 to the 0.83, right? If I wanted to find this z critical, I would have inverse norm, and that would be 0.915, right? And then a mean of 0 and a standard deviation of 1. They should both give me the same number, right? What I did there was I took 0.83 plus 0.085. That's where the 0.915 is coming from. That is going to give me this z star here. The inverse norm of the 0.085 would give me the other one. Okay, so hopefully you remember where inverse norm is on our calculator. If not, we'll review that now. It's second in the variables key, and there's number 3 is inverse norm. So the area, we'll do both of them, and you'll see you get the same number, just one's going to be positive, one will be negative. Okay. So there's my negative 1.37. Now if I use my second enter trick, and if I just come over here and we put in 0.83 plus 0.085, that was 0.915, right? Should get the same answer. Just one's positive, one's negative. So if we go back and look at what they're looking at for an answer here, the z critical, it would be a plus or minus, but we'll give them the positive value. I'm curious. I wonder if we could put in either one, 1.37 or negative 1.37. Usually we would put in both. Usually I put a plus or minus, and they would just want 2 decimal places. Okay. So I'm not sure if they'll take negative 1.37, either one, but it's really a plus or minus type of deal. Okay. Number 6, same thing. I'll do it a second time in case we didn't quite get the hang of it there. So if this time I want 85% confidence, what happens here? We're talking about 85% the area under the normal curve living in there. So down here, this will be a negative value. This one up here will be the positive value, but both are critical values. So remember, the area left over in the two tails is 0.15, but if I divide that by 2, I'm left with 0.075. Right, so 0.075 would live in here. So just as a test, let's check and see if we inverse norm. I'll just use second enter. Now, I know I can get this right if I just put in positive 1.44. But let's just see if we'll get it right if we put in negative 1.44. See if they cooperate with us. Nope. They want the positive one. So that's fine. We'll call it 1.44. So don't do that. Yeah, give it the positive answer. Okay? But if you want to make life easier and not have to add the 0.85 and the 0.075, put in 0.075, like what we're saying here is that this is negative 1.44 here, and this is positive 1.44, right? But they just want the positive answer, so just give them the positive version of whatever you come up with. Okay. I'm going to take a jump to number 8. Okay. So here we have the margin of error, and we want to find it, right? So the confidence level is 95%. The value for sigma is 3.2, and the sample size is 100. Okay. So they want the margin of error. So remember, the margin of error is what we would add and subtract to the confidence interval to calculate it. So let's clear the canvas here. So by margin of error, we mean anytime we do a confidence interval for mean, we take x bar plus or minus, and when standard deviation is known, we're using z star, and then we take sigma divided by root n. So the margin of error is this whole value here. So for 95% confidence, the z star is pretty familiar to us by now. It's 1.96. If we don't know that, then you use the calculator to find it. We would inverse norm, okay, just like we did in the 2 previous problems, and we're going to inverse norm 0.025, right? Why am I inverse norming 0.025? Think about 95% confidence. What's happening here? 95% lives in the interval. Okay, so what lives in each tail? 0.025, 0.025. Okay, so what happens when I inverse norm 0.025? I get that 1.96 as my z star. It gives me negative 1.96, but we'll, for our intents and purposes, just use 1.96. Okay. They give me the standard deviation is 3.2 and sample size is 100. Okay. And we're going to multiply that by 1.96. So it really just becomes an arithmetic exercise at this point. So I have 1.96 times 3.2 and divide by square root of 100 is just 10. So we can move through that a little bit more quickly. So 0.6272. So 3 decimal places, 0.627. Okay. So let's take a look at 9 and we'll think about this one. So we want 88% confidence, 90% confidence. And the way I always explain this to people is like, look, if you had 88% confidence of making a basket, and then I made the basket bigger, you could have more confidence, right? So my 88% confidence interval is going to have to be my most narrow interval. So this one goes from 55.9 to 59.5. I think that is the most narrow. Okay. They all have the same means. It's not, I'm having trouble dragging this where I would like to. I can't tell if it really went there or not. So then my next level of confidence, 99%, looks like, or 90% confidence looks like would this be this one. Drag him to 18. And then, wait a second. Yeah, 55.5 is lower than those two, all the way up to 59.9. So he would be my 90%, I think. And I can tell just by looking at it that this one looks like the largest. Okay, so it's not letting me enter any of those. Okay, so I finally got them to cooperate with me there. But what I want for my 88%, that's going to be my most narrow interval. So if you want, if you can't see that 55.9, that's going to be shorter to 59.5 than any of the rest of these, subtract. Take 59.5 minus 55.9. Take 59.6 minus 55.8. Just subtract them. But it's going to go most narrow up to the widest. The biggest interval has to be the 99% confidence interval. Okay. So number 10, we're actually going to go ahead and construct our confidence interval. So I want to lean on the calculator for this. I want 95% confidence, but they give me my sample mean is 6.6, standard deviation is 0.9, and sample size is 45. So what does this look like on the calculator? This is under stat, and we go to tests, and it's all intervals this week. So we have the Z interval is going to be the first one that we work with. When we don't know this population standard deviation, we do the T interval. And then for proportions, it's a one proportion Z interval. Okay, so I want just the Z interval. That is for means when the standard deviation is known. And you'll know it right away because it asks you for sigma. We don't have the raw data. I'm going to encourage you, if you have the raw data, we'll go ahead and let StatCrunch handle those for us. I think that's a better bet for us. But let me just toggle back to see what the standard deviation was. It was 0.9. Okay, and that's kind of the first thing it asks you for, even before the sample mean. And then the sample mean was 6.6. Okay, they should give us our confidence level, which is 95, and sample size is 45. So confidence level is already set. We wanted 95, but we wanted a sample size of 45. That's important to the calculation of our interval. And so I get 6.337 to 6.863. Two decimal places. So 6.34 6.86. Check our answer out. I like it. So the calculator will be pretty helpful to you there. Okay, so this is pretty much the same as the one we just did there. I'll skip that and take a peek at number 12. Use the confidence interval to find the margin of error and the sample mean. So they give us a confidence interval that goes from 1.49 to 1.95. Let me double check that that's the right interval that I just saw there. Yep. Okay, so they want to know what's the sample mean. Well, that's the X bar that lives right in the middle of these two. That's going to be easy. Just take 1.95 plus 1.49 and then divide that by 2. Okay? How do I get the margin of error? Well, the margin of error is what I add to this to get my width. So I just almost do the same thing. I take 1.95 minus 1.49. And then I divide by 2. Okay? So I take the two endpoints of the interval and I add them to divide by 2 to find out where the middle is. To find the width, I subtract them and divide by 2. Okay, so 1.72 is the middle, and then the width, if I just want to be quick about it, I can hit second enter, bring back up that last command. It might save me a little bit of time, and then I can just tell the calculator to subtract that 0.23. So 1.72, 0.23. Okay, so I should probably read before I type that in. It asks for margin of error, not the mean first. It asks them for them in a different order. So I did the mean and then the margin of error. And we're good, yeah. So read it before you enter the answer, and sorry about that. All right, let's skip, take a peek at number 15. So we have a random sample of 49 business days. The mean price was $119.56. And they give us the population standard deviation of $10.47. I'm going to calculate a 90% confidence interval. So I'm just going to use the calculator for this, right? Stat, we go to tests, and this is the Z interval. Everything in 6.1, if you want to make your life, if you want to oversimplify everything in 6.1 is Z interval. Oh, so we're going to do both. We're going to do 90% and 95%, so we'll just rerun it again. So the standard deviation is 10.47. Good thing about this is the calculator will keep everything in there for you. The mean is 119.56. That was our sample mean. Sample size was 49 business days. And we're going to do both. We're going to do 90%, I believe, first. Make sure you put a decimal in there. It's 0.9. And then it'll be easy to rerun it back for 95%. So for 90%, we've got 117.1. to 122.02. And we're good on that. And then for 95%, real easy. Watch what happens. This time when I go to stat and test, and I do my z interval, I still have all my stuff in there. All I have to do is come down here and change that to 0.95. Uh-oh. Don't do that. Okay, 116.63. And 122.49. Okay. All right, so I hope this is a helpful little tutorial for your 6.1 homework.